make sense?
Yes.
So as I'm going through here and looking at all of this, I want to go ask this kid what was going on, because you so far outperformed what you were supposed to do. My word, son, you did great. So what did you do that did so great? I mean, I would follow up with some questions. And in that same vein, I want to look at the negatives. And, 0.01 difference, that's not enough to worry about. 0.05, probably not. But this kid is a full half point lower than he should be. Does that make sense?
Yes.
And there's another one, a full half point lower than he should be. Should have been a 3.8 and is actually a 2.8. So
those are the students who they are studying more, but their grades are not aligned with how much they're studying. Those are the students who study high amount of hours, but they're still having a low GPA.
So those two that are half GPA points off of the prediction, I just need to know why. These others that are 0.0 something, I'm okay with them. Even the one that's 0.3 over, that's not 0.3 under.
Right.
So I've got two that are relatively high. I've got two that are relatively low, but then everything else is not far enough away from zero to matter. Does that make sense?
Yes.
So that's why this is such a good predictor and outcome variable. You with me so far?
I am.
Okay. So now, can you go to? Make sure I get to it. I think that it is the other Creighton. I think it says extended. Regression sample number 2, Creighton extended.
Yes, I have it.
Okay, so it's right there for you, all of the data. But now look at all the kids. So 59 kids. 59? 59. So go back to sheet 1 and run it, and then look at that output table and see if your data lines up with it.
So rerun the data off of this one?
Yes, ma'am.
It's not letting me. Oh, okay. Wait a minute. I got to click edit, enable editing. There we go.
So make sure you do grab the headings, right?
Oh, so I'm taking the one off the sample regression one and adding to this one?
I added many more students. Remember, there were only 10 to start with, and now you've got 59.
Right.
So
I'm not creating a new one. I'm just flipping back and forth between the two to see if the data is aligned.
Yes.
Okay.
What I want you to do is use sheet 1 instead of sheet 2, which says output table. I want you to see if you can take this data and get the same. So what goes into input Y? What's your Y range? Column A or column B?
My Y is going to be the grades.
Exactly.
Column A.
Good. So instead of grades, I could say it's going to be the dependent variable, right? So I'd write somewhere Y is always the dependent variable.
And X is the independent, which would be, in this case, the hours of study.
So right now, we only have one predictor variable. But if we had others, like column C, if that was a different variable, we would do B and C into the X range slot. That make sense?
Yes.
So my labels are checked. My output range, I just want to put it here. And don't worry about the residual spots. You know what that means already. So, should be able to drop this up here.
I ran a practice one on the regression workbook, 5th grade. I guess it's 5th grade. That it had multiple columns. Because they told me that you guys did that in class.
Yep.
So I have that one already done.
Okay. So what is the correlation value between this extended data set?
On the extended, let me go back. It would be the 0.59, right?
And remember, use
Am I on a different page?
Are you seeing mine?
Oh, okay. I'm sorry. I'm on my own computer looking at the extended one. Well, on the one that you're looking at now, the correlation value would be the 0.66, right?
The one that I'm looking at now should be 0.59.
Oh, okay. So it's stuck on your old screen, but on my personal computer, I'm looking at the one that's 0.59. When we have that decimal, we don't have to say the 0 in the front, right? And we don't put the 0 in the papers. We just say point. Okay.
Yes, ma'am.
So yeah, I'm looking at the one on my screen. It's the correlational value is 0.59.
Perfect. And that's what's on the screen here now, right?
Yes, it is.
Okay. So, got an end count of 59, and I've got 58 down here because 59 minus 1 gives me that 58.
59, mm-hmm.
Good shape. So again, I just like to go through and get rid of all the stuff that does not interest me. I just don't want it. Okay. So what do you think about that number right there? Is that a significant number? Is that number significant?
No.
Well, what does E-07 at the end mean?
I'm not sure.
So what does that mean is that it's an exponent.
It's an exponent. Oh, so I have to move the decimal.
Yes, you got to move the decimal to the left 7 spaces.
So it would be significant.
Yeah, there's 6 zeros in front of that 7. So with that, oh my gosh, that's really strong significance.
Right.
And think about these two down here. And remember, we have it up here, so shouldn't it show up right here?
Right.
Exactly.
It's the exact same.
And look at that one. It's even stronger. 7 is even. Woo. That's pretty strong stuff. Working so far?
Yes.
So, as long as I have my data here, I can take this thing and turn it into I can turn it into
The model.
regression model.
Regression model. So that would be 1.65
Yes, ma'am.
plus 0.31 times x. Correct?
And what is this we're trying to predict? Still GPA.
Okay.
So it's a little different, isn't it?
Yes.
We're starting with a lower average GPA for Joe average student. That makes sense?
Mm-hmm.
But the variable component is larger from 0.28 now to 0.31. So now with 3 GPA at 3 hours of study, the GPA goes up almost a full point. That making sense?
Yes.
Okay. So I thought I did not hit the residual output. But, it's still, look at these. There's 3 of them in a row where the kid overperformed by a lot. And, I would go through looking at this just to determine.
0.5, 0.8, and 0.9. I see it.
And it's not that these are bad, but why am I being surprised when they're a half a point higher than, I was projecting them to be? And, like I said, it's just a situation where you want to be able to go and have conversations with these kids about, wow, what's going on that made your GPA so much higher? And, it's legitimate. It's okay.
So would those be like your naturally higher performing students?
Yeah, the kids who just get it.
They just get it.
Right?
Mm-hmm.
So I looked through the negative numbers, and if it was a high negative number, I'd want to know that reason too. There's one I have to go talk to. Can't miss that. So when they're negative numbers and they're high, man, I've got to go find out why.
There's a negative
And here a couple of
5.
almost a half a point.
Mm-hmm.
It can be a number of things, but when the student knows we're checking up on them, they love it. It's not that you're trying to chew on them or anything like that, but I had you projected to be a 3.7 or 3.8 student, and you ended up at 3.3. 3.3 is not bad. I'm not complaining about that, but what went on? So just the residual output table. Can you see the use of it?
Yes, because it tells you if they're performing at a rate that they should be.
Or they're not performing where they should be,
Yeah.
or they're overperforming.
Or overperforming. Or if you have a student who's studying a lot of hours and they're still not, and they're underperforming, you may know, well, studying is not the issue. We got to figure something else out.
That's right. Maybe what the teacher is doing isn't, transferring home with them.
Mm-hmm. Yes.
Okay. So let me look here just a second. All right, so you opened this, right? 5th grade science curriculum.
Yes.
Did you take this and put it into a spreadsheet?
Yes, I have it on here. Let me pull it up.
So you also see that regression workbook, 5th grade, has this. It's already copied over for you.
Mm-hmm. Well, and so I did it with I did it with Miss Tracy Crouch. She was trying to tell me from her notes of how to do it. And I can find where I downloaded your copy, but I had to open mine in a new Excel and I cannot find my work. But that's how I knew what I needed and what I didn't need.
Okay, so you see there's a number of summary outputs here, and now we don't have one predictor variable. What do we have?
We have a lot of them because we have all of these Rigsaw 1, 2, 3, right?
Benchmarks, exactly.
Mm-hmm.
So now we have 3 predictor variables, not 1. So that does change up the regression model. So and oh my goodness, there are not 1 but 2 dependent variables. But Rigsaw is trying to predict scale scores for science, not the end of year grade.
So that's just extra information for this particular assignment. Okay.
It does give you more information than you needed. And yes, he's just evil that way. But it is to get you to thinking, because wasn't this the assignment in your reflection 2?
Yes.
The correlation? Didn't you run a correlation between EOY and this?
Right. Yeah.
So think about this with me. What if this correlation between EOY and 5th grade science scale scores was stronger than these 3 benchmarks and the 5th grade scale scores? If this was stronger, this would be a better predictor. And it's just been a single, not a multiple regression. Makes it simple regression, multiple regression. So, but let's go on.
So if
and
we were
run.
doing a simple regression, we would only do end of the year and then grade 5. It would be those two variables against each other. But since we're not using end of the year, we would use all 3 Ricksaw in the map scores, and that would be a multiple.
That's right.
Gotcha.
So how about if we get...
We don't need that end of the year. We need all of that.
Well, I included it because it was in the way.
Okay.
Copy this and put it into a clean sheet so we're not confused by anything. Okay, so the first thing I want to do is get my tool pack opened up, open up the regression, clean all my junk out, right? And now, again, y is dependent or independent?
Y is your dependent.
The dependent variable. So in this, I'm going to make sure my cursor's in. Which one am I going to go get?
The last row, grade 5 science.
Yale School. And now, I'm going to get all 3 of the 1, 2, 3, and all the way down. I use my labels on an output table. I don't want residuals right now. Ooh-wee. Look at that correlation. 0.97. Holy cow. You with me so far?
I am.
Okay. Okay. And it included them anyway. I didn't have that checked. I didn't think. All right, so I got all 50 of my kids. I've got 49, but ooh, it's 3. But 49 is correct because n minus 1 is still 49. Okay?
So that 3 in the regression is because we have 3 variables?
Yes, ma'am. 3
Yay.
predictor variables.
Okay.
Exactly right. That's wonderfully put. Okay. So let's think of it this way. This significance F is telling me what the model is. Is the model trustworthy? Is the model producing significant results?
Yes.
Significant.
Because it has to be moved. You have an exponent of 29. So the decimal will have to move to the left. 29. That's very significant.
It is. But then I have to come back down here.
We don't need those two.
That's right. Just want to move them left. Everything will be okay. Now, these p-values, I'm just going to mark them yellow for significant. And then I'm going to mark them.
And those 3 should equal that one significance number, right? Would they equal?
No, ma'am.
Okay.
So there's no equivalence here. This is, you just look at these predictor by predictor by predictor.
Okay.
So, in order for the model to work, we have to give every kid 112 points to start with. That's kind of weak. I'm just saying that's so far from 0 that it's problematic.
Mm-hmm.
So, I look at number 1. Ricksaw 1 is not a 0.05 or lower. That's not an accurate predictor. What about Ricksaw 2?
No, it's not.
And it's even worse than Ricksaw 1.
Yeah.
0.71, 0.72, it's so far away it's not funny. And then finally with Ricksaw 3, I get another, well, I get the model it just from Excel, working and making a regression model. If it is significant at all, if it can be significant, it will be significant right here and in the intersect. So I'm paying for 2/3 of the predict to be effective. You think I'm happy with this?
No.
I'm not happy with this at all. I'm wasting 2/3 of my money. So as a superintendent, we're not renewing this. That makes sense?
Yes, because only a third is significant. Not even half.
Right. So, I mean, you can go through here and you can look at all the kids with 4 points or more difference. A lot of these things are negative too. Almost 9. That's
So the residual numbers here are a lot bigger. So we're not dealing with small decimals. We have whole numbers involved.
Yeah, but think about, the scale scores go from 0 to 200.
Oh, okay.
GPA went from 0 to 4 only.
Right. And
so these are by nature going to be larger.
Right.
But still have a lot that are 3 and 4.9 points away. Not many zeros as I look down through this 0 something. So I can look at that and say, ooh, that's not accurate. I'm paying for accuracy and I'm not getting it. So your jack